You can try this one on your own first. Okay, let's see the solution to example 6. In the figure above, this triangle ABD, AD equals DC, angle B equals 30 degrees, and segment AB equals 10. What is the ratio of AC to CB? Okay, here, first of all, notice that in the SAT, the notation they use to refer to line segments is always two capital letters referring to the two endpoints. So AD means this segment here, right? But at the same time, this notation can not only refer to the segment itself, but also to the length of this segment. So saying, for example, AD equals X, that means that X is the length of the segment AD. Okay, so we are saying that AB equals 10. Obviously, here is 10. You don't need to actually have this explicitly because the diagrams informs you so. But then we have that this angle is 30 degrees. Segments AD and DC are the same. That means this is X and this is also X. Okay? What else? Well, we need to find a ratio, AC to CB. In other words, we need to find this quotient. What is this? Can we solve this? Okay, let's see. First of all, something interesting is that since triangle ADC, the one with the sides AD and DC, is an isosceles right triangle, so clearly this segment here must be X times the square root of 2. It's an isosceles right triangle. At the same time, this is a 45 and 45 degree angle. And because triangle ABD has one interior angle of 30, that means that the other interior angle that is not the right angle that is here, this angle here must be a 60-degree angle. So how do we find AC to CB? What is AC? Take a look. AC is this part, is this side here that we define as X multiplied by the square root of 2, right? We can say that in terms of X, AC equals, is the hypotenuse, so it's X times the square root of 2. What about CB? CB is this side. Can we find a connection between CB and X? Well, think about that for a moment. If this is X and the hypotenuse is 10 in triangle ABD, it follows, because of the properties of the special triangle with angles of 60 and 30 degrees, that this must be half of the hypotenuse, that is to say 5. But if this is 5, then what happens? Well, obviously, the connection between the shorter length or the shorter leg and the longer leg, that is all of this. This is the longer leg. What should be the longer leg in terms of X? Well, according to the properties of this triangle, 60, 30, and right angle, if this is X, this should be X times the square root of 3. So what is the length of DB? DB would be actually 5 times the square root of 3. Okay, good. Now, what about CB? CB plus X is dB, that is to say 5 times the square root of 3. So according to this equality, the length of this side, the segment CB, should be 5 times the square root of 3, take away x. Okay? So now, if we substitute this expression here, so we are forming this quotient, AC, which we know is x times the square root of 2, or we can now write it directly, right? Because it's 5 times the square root of 2, okay? And divided by CB, which is 5 times the square root of 3 minus 5. Well, we can clearly see that 5 can be factored up and down because we have this. And we have, sorry, square root of 2 is missing. Square root of 2 divided by square root of 3, take away 1. It corresponds to option